Hi, I want to talk briefly about the law of cosines. So previously we did the law of sines, and the law of sines primarily dealt with the congruence you got from basic geometry from ASA, angle, side, angle. The law of cosines is going to help us deal with two remaining situations, right? One of which is SSS, right? If I have this, can I figure out the angles? Well, presumably I can, right? We know that there's only one triangle up to congruence that does this. And we saw a little bit about SSA, in which case I want to be able to figure out what that third side is, again, by what we know from back from geometry, that's uniquely determined. And the law of cosines is going to get that for us. And the law of cosine says that if I have a triangle, and I'm going to have one side C, so that's a little c, and there's a big C here, big A here, little a here, little b here, big B here. Sorry, other way around, big B up here, consistent with how your book does it, little b down here. Then c squared, that is our little c, equals a squared plus b squared minus 2ab cosine c, little c. This should look to you very close to the Pythagorean formula, right? Pythagorean formula for a right triangle would be exactly what you get without this last term. And hey, look what happens if big C becomes a right angle, 90 degrees, pi over 2. The cosine of pi over 2 of 90 degrees is 0. So this term will go away. So you can think of this as a generalization of the Pythagorean formula. And let's prove this. All right, maybe I'm lying to you and it's not really, doesn't really work that way. We always want to prove things if we can. So this is our goal. I'm not going to erase it. In fact, I'll circle it so remember we're working towards this. And let's set up something very similar to what we just saw. So we've got a big C, like little c down here. Big C is our angle down here, over here. We've got big B here, little b, big A, little a. I'm going to put a perpendicular down here. And think of this as splitting this up into two pieces. I'm splitting C up into two parts. And I can write those in terms of, hey, I know A and I've got little b. So this is going to be exactly A cosine big B. Because the ratio of this to that is a right triangle. This is the adjacent side. Better this side divided by A, better give us the cosine of that. So divide out the A to get cosine B. By the same logic, this side, this section, needs to be B cosine A. All right. So we get that C equals A cosine B plus B cosine A, which is the same as saying C squared equals AC cosine B plus BC cosine A. All I've done is I've multiplied everything by C. And now I want to note something important. There was nothing special about doing this with respect to C. I could have made the same breakdown for A and added an altitude here, or done the same breakdown here and added an altitude for here. So we need to get the same looking thing for A and B. And if I do that, I'll have A squared equals AC cosine B plus AB cosine C, right? The rule is you've got the squared version here, and then each of the other terms are the cosines of the other two angles, and for each of those you have the pair over here. So in the same way, we'll have B squared equals BC cosine A plus AB cosine C. And now we do the fun bit. We take A squared plus B squared minus C squared. A squared plus B squared minus C squared. So A squared plus B squared is going to have all of these terms. Right, you have an AC cosine B, a BC cosine A, and then we're going to be subtracting C squared from it. Okay. So these terms are going to get removed. These terms are going to get removed. The only terms that don't cancel here, AB cosine C, AB cosine C, right? This term will get canceled by this because we're subtracting A squared from there. And this term will get canceled from there. So this is 2AB cosine C. And now to get that, we bring the C squared to that side, and we bring that term over to that side. Right, and then we're done. Right, bring that over and that over, and that's exactly that proof. All right, how can we use this? Well, we can use this, and you'll see later, is we can use this now because given an A, a B, and a C, little a, B, C, I can find that angle. And I can use that to work out angles. Or given that angle and an A and a B, I can work out C. So that's the basics of the law of cosines.